Now, the big question I'm going to ask you is this: have you ever wondered, when galaxies collide, what happens? In this video, we're going to look at NASA's image that was released using the James Webb telescope about this incredible galaxy that was actually showing these particular characteristics. This is actually called the Cartwheel Galaxy, and in this video we're going to look at, first of course, what are galaxies, and then different structures that you can come up with when it comes to a galaxy. What are the properties of a galaxy and how those properties can impact when other galaxies are interacting with a galaxy. I'm going to look at this particular image, which is going to be mind-blowing, couple of things that have never been seen before, and what are the impacts or the symbolisms behind some of the interesting coloration and stars that you see there, and how the structure impacts what happened and also what may happen to our Milky Way when maybe something happens, not now but in the distant future. So let's begin. Now, first, the question is this: what is a galaxy? What galaxies are is the following. Galaxy in a universe we know consists of the following. Consists of one, we have the combination of stars, and some of the stars can be born, some of them might be dying stars. We also have gases and dust present around that particular system, and finally we're going to have a couple of interesting strong gravitation that is holding this together through attraction. There is still one more thing that is left in terms of a black hole, and we're going to talk about that very soon. Now we're going to look at the next part, which is the different galaxy structures that are out there. There are in general three, as we see right here. But first, we're going to look at this particular image that is shown right here, which is called a spiral structure. And this spiral galaxy has two different types. One is called a normal spiral, and while the other one is barred. And this here, for both of them, or in general spiral, are really known to be flat in terms of their structure. And in addition to that, it has a blue-white star disk, and in addition to that, it's known to have a very high star formation. Now, this in contrast to another type of galaxy in terms of the structure, as we see in this image right here, is known to be called what? Irregular, mainly because it is neither a spiral or it is the last one, which we're going to talk about very soon. And the reason why also is irregular is because it has little dust present, and also in addition to that, it looks back in time, which is really important in terms of how we describe and analyze different images that are gotten from all the telescopes that we've actually had, and also how we can look back to how many years that this image is actually taken for, how many light years away, because of the background lights or stars that we see right here relative to the shining ones that we have right in front of this image. This here is first formed before other galaxies that we know of, because from the irregular image we can now see how galaxies can actually come close together and form either spiral or elliptical galaxies. And elliptical galaxies, we notice that there are two forms of this. One is either it is circular or elongated, and in addition to that, there is low amount of gas dust. In addition to that, there is a high amount of old stars, and this impact shows that there is a decrease in star formation. These galaxies are known to be around 1/3 of the whole galaxies in the universe. And finally here we have, this is formed from combining small galaxies together, like going from irregular to elliptical. There is another way that elliptical can be formed, and this another way we're going to talk about this in this particular video. Now let's look at an example of a particular galaxy, which is called Messier 87 supergiant galaxy. And this image here, as you see on the right side of your screen, using the Hubble's telescope. And this actually is really important because the Hubble telescope used a specific wavelength, which is around this particular region, the visible in combination with the infrared, to produce this particular image. And so what we see in this image is a couple of things to be aware of. There is this particular strip here of blue jet. We also call this a relativistic jet, and the reason why it is called a relativistic jet is because when particles fall into a particular property here, which is the galaxy part, the core contains a black hole, all those particles that go in will actually release couple of particles that comes out, and this release of particles are usually subatomic particles, and these subatomic particles, they are in this particular part moving really close to the speed of light, and this is going to create this particular blue jet that is noticed. Other things that are interesting here in terms of speaking of the black hole is that black holes indeed are found in majority of galaxies. And in here what we see is that in this image that was taken using a specific type of telescope, which is impressive because it is on Earth, and this telescope is a combination of many telescopes that over time took various images and analysis were made in our way to generate our first image of a black hole. This is shown to be a very impressive way by which we can actually see how one method can help to understand this particular phenomenon, but also what is our next telescope, which is James Webb, going to produce in terms of the imaging in the future. This here is actually 55 million light years away from our particular Earth region, and this here is called the Event Horizon Telescope, which was used to generate this particular image. Now let's talk about what happens when galaxies they collide. And so when galaxies they collide, there are a couple of things to be aware of. First, is this actually possible? Yes, it is really possible. Reason is because that although we know that galaxies tend to be further away from each other, there is something that's interesting in terms of an individual galaxy, and that is that the diameter are so large to the point where in some point they are relatively interact with each other because they will be really close. Therefore, this results in how galaxies, when they come together, they don't just collide, they actually pass through each other, and this passing results in the following. The stars, they don't collide because stars are relative to that of galaxies. They are small and they have larger distances among each other, but there is something that's going to be interesting that happens when they collide. They actually form new stars. As a result of that, new supernovas can be created, black holes can be created here. And this is interesting because the way an individual galaxy produces those stars will be completely different from that of the new stars that are going to be formed in terms of the process. And another thing will be noticed here: the shape of that particular galaxy will change, and the shape of the galaxy when they actually interact with each other or pass through each other highly changes majority of the time from this particular individual step to a collective step, which is more elliptical. So this is another way ellipticals can be created when a particular spiral or another galaxy interact with each other, according to astronomers majority of the time. And now we're going to dive really deep into the image of the day that was released by NASA using the James Webb telescope. This image here is known to be called the Cartwheel Galaxy, and this galaxy was actually 500 million light years away from Earth. And this is incredible because this image was taken by the James Webb telescope, and using the region of our wave or light spectrum is actually not here, which is visible, which we can see, but uses the infrared, specifically the mid-range and the near-range region of that particular infrared spectrum. This here is a far range region, which is more towards the longer wavelength. So that wasn't used in this particular generation of this image. So let's begin with the following. Now, what we see at the background of this Cartwheel Galaxy is that we have other galaxies, neighboring galaxies around, and these neighboring galaxies shows that they are majority of the time really spiral. And we have one there and we have another one here, but then looking closely at this particular Cartwheel Galaxy, we see a couple of interesting things that led to the creation of this galaxy. One thing that was really spectacular is that it was explained that how this was formed was due to one particular galaxy which is highly spiral and is really large and huge, interacting or colliding with a smaller galaxy, and there is no description on what the characteristics in terms of the shape of that galaxy is, but when they come together they collide, and this results in a particular formation of what we see right here. There will be other proof to show that this was actually caused by a collision process. Now this process here was done around 400 million years ago, so we can see the past. Now can we see the future? That's going to be something to think about in this particular video or for the James Webb telescope. Now here are the proof, looking at this image, that yes, this was done due to collisions between galaxies. One thing to observe is that we have the core of this particular galaxy, and around it we have two rings, one which is right here and the second one which is the outer layer, and these two is actually similar to when something happens physically where you're around your surrounding. It's similar to when you drop a particle in water, you see these ripples that are actually generated. That is exactly what we are seeing right here. And also this is actually describing a potential new type of shape that is created by galaxies called a ring galaxy, which is what astronomers are calling this around. So it's going to be interesting to see whether this is going to be added now to the list of other new structures of galaxies or not, and what makes a structure to be new or a structure to be valid. Is it because it's just an individual galaxy, or is it because other galaxies interact with each other forming new types of galaxies that is not, in terms of the structure, agreeing with the three general galaxy categories? So it's going to be interesting to see the thought process behind that. Now next is this core here, which is the center. What are the things that are present in there? It is thought that there are three categories of properties that are present in here. One is that yes, we do have a lot of nice particles and dust that are actually around, quite diverse amount of those things happening in there, but also we have a couple of interesting stars that are actually forming in this particular center here. Now these particles here also includes gases as well, and finally here we have this here, which is a black hole. It could be one, it could be many black holes. We don't really know yet, because we have now two galaxies that actually collided. So will their black holes interact in a way due to effects of gravity? We don't really know yet. So it's going to be interesting to see those questions to be answered. Now in terms of the outer space between the first ring, inner ring, and the outer ring, we have a couple of red colored that are shown right here, and this red color is a combination of hydrocarbons, and we're going to have some interesting gases present in there and chemicals that are not identified yet, but we're going to identify those soon. But also we have silicates that are present. This is really important in terms of developing this interesting exterior skeleton that is streaming around the regions between the inner ring and the outer ring. So that is really fascinating to see this. Now let's look closely at the mid-range of this particular galaxy. Quite a spectacular coloration, and this particular mid-range is actually between this particular region of 0.6 to 5 microns. And so when we look closely, we look at the outer regions and we see a lot of distortions that are present. We have this distortion here, and these distortions, you might be wondering what caused this distortion, why the distortions. Is one of the effects, of course, of when things collide and then produce the after effect. And this also shows a couple of interesting things here. Around this outer shell, we have blue lights. The blue lights here represent star creation, according to not only some regions here, but also around this region. So it is proposed that there's a lot of star formation happening right here and less star formation happening right here in terms of the activity or level of activity. In addition to this, we also have a couple of supernovas that are present around this particular region of the outer ring. Now, in addition to that, we also have this particular expansion of the outer ring that is shown right here, and this expansion lasted around 440 million years, which is huge and humongous. So now we're done with analyzing these images. We're now going to look at the effects of how galaxies and what are the implications when galaxies they interact or collide with each other. And this includes the following. Our galaxy in this case is the Milky Way, and it is believed that in 4 billion years from now, our Milky Way is going to be interacting or colliding with a distant galaxy, which is the Andromeda I can't pronounce that word properly or fluently galaxy. And this here is going to be interesting because yes, this galaxy, also short form M31, is 2.5 million years light years away from our specific planet. And so this is going to be interesting because we're going to have a couple of interesting things that are contributing to the collision process. One is both galaxies, they have their own gravity, and their gravity will be interacting with each other as well as their dark matter. So this is going to be impressive in terms of what are we going to, what are the impacts of this collision. It's thought that Earth won't be impacted by this collision process, but I'm kind of curious how would that influence our gravitational field, because there are other things and also other stars that are around our own particular Milky Way, and will those stars impact our own stars gravitational field and in return affect us? Only time will tell in that particular case. Are we going to live to that particular point in time, 4 billion light years away? I don't really know. Will our stars survive another 4 billion years before this event happens, or will our star become a supernova by then? We don't really know at all. So it's going to be interesting to see this effect in the future, but cool thing to see. And you can actually see this close interaction between these two galaxies in this particular image as shown right here. And so I hope you found this really informative in terms of how galaxies they actually interact with each other, what are galaxies, the structure, the impact, and the image was released by NASA. And I hope you found this really informative here. Please hit the comment down below. Let me hear your thoughts about this interesting characteristics of the Cartwheel Galaxy, and what are your thoughts about the future outcomes of this particular galaxy as it relates to our own galaxy, and also other relationships that you might come up with. All the same, thanks for following me through this. Really appreciate it. Hit the comment down below. Let me hear your thoughts. By that way, I can talk to you soon. Stay smart as always and believe in yourselves.